You probably didn't see much of this in Algebra 2 if that's where you're coming from, but you might have. It's actually in the Algebra 2 book, they did have like probably an extra page in there that talked about this. Compound interest. Does anybody have a savings account? Probably a few, right? You probably, on your savings account, you earn a certain annual interest rate. You know, let's say it's 6%, which is way too high, but let's just say it's 6%. It's not like at the end of the year, they calculate 6% of your balance and they give you that money. What they do is, at the end of a month, they calculate 1/12 of the 6%, and they give you that money. And then the next month, they do the same thing. So every month, they're giving you 1/12 of the annual interest rate. Now, that works to your advantage because, I mean, when you calculate that interest the second month, you get not only the 6% divided by 12 of, you know, whatever you've got in the bank, you got that increase that you were given at the end of the first month, right? So that's the compounding part. You know, every month you get something added, you get that interest rate calculated, or the interest calculated, you get a little extra interest. It's how investments, it's how savings, how everything like that works. Okay, the things that are in this formula, right? The A is the amount of money that you're going to have, right? A is the amount of money. After so much time. The P is called principal, right? Spelled like the principal of a school, P-A-L, right? And that's the initial amount of money that you put in. Right? If you put in $100 at the beginning of the time period, then that's the principal. The R is the interest rate, annual interest rate. If 5% is the annual interest rate in this formula, you put 0.05, the decimal value, right? Don't put 5, put in 0.05. The N is the number of compoundings per year, right? If it's compounded every month, that's 12. And P is the number of years that you're talking about this investment. Now notice that, let's just say you compounded, that N was 12 monthly, and then you compounded for 2 years. How many separate compoundings is that? It's 24. So this exponent here is the total number of compoundings. It's the number per year times the number of years. There's times when we end up dealing with less than a full year, so it becomes important then. How are you going to come up with the exponent? It's the total number of compounding.